Hello everyone. Today we are going to discuss about nodal analysis. Last session we are discussing about the mesh analysis. We are all knowing that both mesh and nodal analysis are used for circuit simplification and finding the particular voltage, particular current at a particular component. In the nodal analysis, in the case of mesh analysis, we are writing the number of equations based on number of meshes that the circuit contains. But in the case of nodal analysis, we are finding the node, and based on number of nodes we are writing the number of equations. Here to explain the nodal analysis, I am simply taking a circuit. First of all, what is node? Node means simply joining point of a two components is called node. But here in the nodal analysis, we are writing the node that is connected three components. That is called junction. That is also called as junction. Here in this circuit, we are taking the three resistors and one capacitor, simply writing the nodal equations. Here we are finding the trijunction. The voltage at that junction is marked as V0, and first we have to mark the node voltage V0. This is the unknown one. Next, we have to write the voltages at different nodes. This node is directly connected to the ground. This node is also directly connected to the ground. That means here zero voltage is present. Here, but how we are writing the nodal equations means, from the V0 we are going to take the current away from the V0. In this direction, negative minus positive, in this direction. So I current will be divided into 3 into I1 and I2. So I is equal to I1 plus I2. This KCL equation is base for the nodal analysis. So from V0 minus V1 by R1. Here why we are putting minus means, here the current direction is we are taking in the opposite direction. Similarly, V0 minus 0 by R2 plus V0 minus 0 by, here there is a series connection of impedance, R3 plus 1 by j omega C4 is equals to 0. So here I is equals to I1 plus I2, simply KCL equation. If you have the second node in this circuit, then we have to write the equation same as above, and we have to solve by using the matrix methods. Here we are taking an example problem. Here overall three resistors are present, 2 ohm resistors and one 3 ohm resistor, and 2 Henry inductance is connected in series with the 3 ohm resistor. Here we are going to find the first point is volt. We are going to find the node. Here the node is trijunction node is between 2 ohms ohms and 3 ohms and 2 ohms is both these three components are connected at one point, that is called as voltage V1, that is called as trijunction node. In that junction we are marking as the voltage V, and here the voltage source 2 volts is at another node, another 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 node of a 2 ohm resistor. Here in this 2 ohm resistor, another node, there is a ground means 0 volts. In the 3 ohm plus 2 plus j omega 2 also has a these 0 volts. So now based on the above explanation, we are writing that nodal analysis means V minus here we are writing nodal analysis. We are finding the node. Then we are giving the unknown variable V. Now we are going to writing nodal analysis by V minus 2 volts by 2 ohms. Here we are putting minus because we are taking the current in opposite direction. Next plus V minus 0 by 2 ohms. Next V minus 0 by 3 ohms plus j omega 2. Here j omega L is the impedance of the inductance. So we are writing plus j omega 2. These three are currents flowing through the resistors. Here impedance of the inductance is j omega L, that is equals to j 2 pi fl. F means frequency, but in this circuit 2 volts is a volt source. 2 volts voltage source is a DC voltage source. That's why we are writing for the DC voltage frequency is 0. Frequency is 0 is substituted in this j omega L. Then impedance also 0. So there is a short circuit between 3 ohms and the ground. So we are writing j omega 2 as we are considering as 0. Now we are having 3 ohms resistance only. We are simplifying it as minus V by V2, V by 2 minus 2 by 2 means 1 minus 1 plus V by 2 ohms plus V by 3 ohms minus V by 2 plus V by 2 is getting cancelled, and finally we are got V minus 3 by 3 is equals to 0, that is equal to V is equal to 3 volts. So we are finding the unknown voltage V. Similarly, we are having the number of nodes. Then we are using the matrices methods for solving these unknown variable V. Now unknown variable V. For listening this, all of you thank you. All of you thank you. Hello everyone. Today we are going to discuss about the basic laws in the circuit theory. Those are KVL and KCL, Kirchhoff voltage law and Kirchhoff current law. First of all, we are going to learn about Kirchhoff voltage law. Kirchhoff voltage law is saying sum of the voltages around the closed loop is equals to 0. Suppose we are taking a simple circuit like this, and here is a voltage source Vs, and there is three resistors R1, R2 and R3. When the current is flowing in this direction, then we are writing the equation as here positive terminal current is entering, so that's why plus r I into r1. ఇది here it is the voltage drop at r1, and then next the current flow is like this, so that's why r2 and I, r2 into I. Next, here the resistors current direction R3 also from positive. So that's why I into R3. Next, the current direction is entering at the negative terminal of the voltage source Vs. So the drop at the voltage source Vs is minus Vs. that that means sum of the voltages around the closed loop is 0, because here the voltage Vs is distributing R1 and R2 and R3 component. Here those are the voltage drops from the R1, R2 and R3. Next we are going to learn about Kirchhoff current law. Kirchhoff current law means sum of the voltages at a node is equals to 0. That means suppose we are considering simple network. Here the current flow is I, total current is I. I is distributing to the R2 and R3 resistors. That's why we are writing at this node I is equals to I1 plus I2. Thanks for watching.